Structural Analysis 2, Chapter 9, Force Method in Indeterminate Structure. So if we have an indeterminate frame, we want to see how we can solve this problem. So in this example, we can easily see we have a fixed support at A and a roller at C, and we want to find the vertical reaction at support C. So we are looking for reaction at C, definitely that's a vertical one, by applying the force method. Let's see how we can solve this problem. So if we can dissect our problem, our indeterminate structure to, this is one determinate degree, our structure has 1 degree of indeterminacy. So if we just consider the reaction at CRC like a redundant, and we dissect our structure like a one without support C and the horizontal force of 4 kilopounds at one edge, and plus the, the same structure with the redundant force, then we can observe our structure. So then by applying the compatibility equation, we can easily say delta 1p, as soon as we observe the delta related to this structure, plus delta 1 to reaction for the real load plus, which is this one, plus the reaction or redundant force. Because in the original structure C has nowhere to go, you can easily see support at C is just settled on a wall support, so the vertical displacement is 0. So compatibility of the formation tells us what is the deflection, and because that's 0, we can easily calculate the redundant reaction at support C. So let's solve our the real moment. So in the real structure, as soon as we get rid of that the support at C, or we turn our indeterminate to a determinate structure, and as soon as we make some cuts for the horizontal member, we call it mx1, and the vertical member like mx2, summation of moment in x1 goes 0. There is no force applying here, so moment at distance of x1 goes 0. Doing the same summation of moment about x2 goes 0, it just gives us a mx2 minus 4x2 due to this force times this distance give us the arm, and it just gives us mx2 is equal to 4 times x2. As soon as we have this one, we can jump to the calculation of virtual moment. So for virtual moment, we just apply a 1 unit force, one keeps 1 kilopounds, 1 unit force in the direction of our redundant or reaction at C, and cut our section again through like small mx, because we are in virtual moment. We release all the forces from the structure and just applying a unit force at the direction of our movement, and again cut the section by a length of x1 and cut the vertical one by a length of x2, and it just gives us again mx1 this time is equal to, this time mx1 is not is 0, it just gives us mx1 equal to, it's like mx1 minus mx1 plus 1 times x1 goes 0, it just gives us mx1 equal to 1 x1. And also for mx2, it just gives us, so this one is x1, and summation of moment about x2, it just gives us mx2 plus 1 times distance, force times arm, give us the moment. So mx2 is a negative 18 kilopound times feet, kilopound feet. So as soon as we have both of them, can show our structure like the real moment and mx1, mx2 for the real moment, like we already calculated this one in the first part, and the virtual moment, which is mx1 is equal to x1 and mx2 is a negative 18. As soon as we have like our moment in the real structure and our moment in virtual structure, by just simply applying delta 1 times p is equal to integration from 0 to L small m capital M over ei dx. So this part, the vertical member, the being one, because this is 0, 0 times x1 is 0, but we just have the equation for the vertical one. So this is the only part we apply. This one, the horizontal part goes 0, so the vertical one, which is the length of 12, vertical length is 12 feet. So that's integration from 0 to 12, small m, negative 18, capital M, 4x2 dx, and it just turns us a negative 5184 over EI for delta 1 P. As soon as we have this one, we can just jump to section for the redundant part. So if we just the second part, creation of second part for virtual moment is pretty simple. We just replace the small m from previous part, but for the real moment, just multiply everything by the redundant. So mx1 and mx2 are simply replaced from the previous part, but this time we are in the calculation of this time delta 1 for reaction. So we just multiply the moment everything by a unknown r. So in that sense, mx1 is equal to r times x, capital R times x, create our real moment, or m capital, and mx2 is just negative 18 but times r capital. Definitely we have to multiply 1 kilopounds by the reaction as well. So 1 times reaction, it just gives us reaction at C. So that's the only unknown. And if we just develop that, delta 1 R is equal to summation from 0 to L small m capital M times E over EI times dx. So as soon as we have that one, we can easily see we have this one for our vertical part. So if we just take out R like an unknown constant out of the integration, it just gives us a 0 to 18 for the horizontal. So let's go for the horizontal part, vertical part first. So that's a negative 18 times negative 18 times r. R is out here, so that's a negative 18 squared. Negative 18 squared dx from 0 to 12, which is the height of horizontal, the vertical component. And for the horizontal component, you can easily go for this part. So it just gives us a 0 to 18 because the horizontal length is 18, and that's 18, 0 to 18 integration of the moment is x1 times r times x1, which already take r out. That's x squared over ea. Forget about 1 or 2 d over dx. And if you just do this math, it just gives us delta 1 to unknown reaction is summation of these two parts, which gives us at the total, it just gives us a 5832 over ei times reaction. Then by just simply applying the superposition in this part, delta 1p compatibility of the formations gives us delta 1p plus delta 1 redundant reaction goes 0, and we already have our delta 1p from the first part of the problem plus delta 1r, they should go 0. So if this is 0, then it just gives us the reaction at support C, which we are looking for, is equal to 0.889 kilopounds. That's all about how we can add up the two components for indeterminate structure get one delta 1 from the determinate structure, get the other one from the delta 1 for reaction for another determinate structure. By applying the superposition, we can have both of them. The only unknown here is our redundant reaction. So that's our redundant reaction, which is our vertical reaction at C. We are looking for vertical reaction at C. We can also solve it with an easier approach, which is the graphical method, which I'm going to solve it in next video. Thank you.